This is Evaluation of Synergistic Chemical Effects on Medical Plastics by Nicholas Chandler, Amy Curcio, and Elizabeth Whiteford. Environmental stress cracking, or ESC, is responsible for an estimated 25% of failures in all plastic components in use. Due to COVID-19, the use of multiple disinfectants and cleaners on the same part has become increasingly common, which can lead to synergistic chemical effects. When a part experiences multiple stressors simultaneously, including chemical stressors, their combined effects can be greater than the sum of the effects when experienced individually. These combined effects are known as synergistic effects.
For our testing, we used a combination of ASTM D543 and ASTM D638, which are methods for evaluating the resistance of plastics to chemical reagents and tensile testing. And we had two phases of testing, the first of which was just individual disinfectant application, and the second was a combination to test the synergistic effects. So the individual results can be seen in Table 1, while the synergistic results can be seen in Table 2. And in order to determine a pass or a fail, we looked for a 70% retention of tensile stress, a 90% retention of elongation, or in the case where it was applicable, a 90% retention of modulus.
6 of our 16 materials were eliminated from synergistic testing due to the failure of all single chemical testing, with 4 of our 16 materials completely passing our synergistic ESCR after being wiped with each active ingredient. However, our failure was inconsistent with no one brand or chemical failing all materials completely. Most of our materials failed in our unexposed strained testing, so we ended up testing 2 materials by examining under a microscope for cracking, which you can see evidence of in Figure 2. We also looked at the concentration of active ingredient in our wipes with our matrix chemicals, leading us to believe that our matrix chemicals in the wipes could be responsible for the increased failures. In conclusion, our amorphous materials resulted in an 18% greater loss in average properties than our semicrystalline materials, with our semicrystalline materials passing at least 2 of the chemicals except for the polypropylenes. Our fiber-reinforced and impact-modified materials did not end up having a greater retention than our unmodified averages, with little to no evidence for synergistic effects in PPSU 2000. However, with all our other materials that were synergistically tested, we did find a decreased retention of elongation and a stable retention of yield strength as compared to the single chemical testing, leading us to belief of synergistic effects. We would like to give special thanks to Professor Brian Young, Mr. William Urban, Mr. Brian McGrady, Dr. Xiaoxi Zhang, Dr. Gregory Dillon, Mr. Christopher Bartlett, Mr. Andrew Bartlett, Mr. Joshua Lutz, and Mr. Adam Gummerson for all their help. Thank you.